Macbeth. To be or not to be?
That's from Hamlet, TK.
Huh? No, I was just wondering what these two bugs are. So many interesting things in America.
We're not anthropologists, we're explorers, adventurers. And our quest is to find the mythical...
Oh, look at that granite! That'll be an awesome addition to my rock collection.
No, TK, come back before...
Someone's up ahead.
Oh, look, a salesman. I wonder if he'd have good information for us.
I don't think that'd be a good idea.
Oh, Fabio, it'll be fine. If it makes you feel better, you can stay here.
It's not like I care if you get killed.
Greetings.
Oh, hi, Mark.
My name's not Mark. You must have mistaken me for
Nonsense. I know a friend when I see one. Now, can I interest you in my wares?
What are you selling, anyway?
I call it fairy dust. Finest quality west of the Panama Canal. Highly concentrated.
Hey
iron.
guys! It wasn't granite, it was quartz!
What a specimen! Interested am I in acquiring this device.
What a coincidence. I happen to be interested in acquiring information.
Tell me more!
Legend regales us with a tale of the item that will save our homeland, the bringer of life, the banisher of death. The item I speak of is... the potato.
It couldn't possibly be more valuable than this rock.
Much more. Also, didn't I already tell you that
Well,
was...
butter my butt and call me a biscuit. You probably want to know where it is. Am I right? Or am I right?
Yes, if you have such information.
Oh, it's just over there. Now, about my payment.
Really, how do I know what you say is true?
I'm no expert in such matters, but that rune of blood is a pretty good sign, literally.
Why, this appears to be written in the ancient native language of the people who first notified me about the majestic potato. Let's see, I might be a bit rusty, but I think it goes to say, to the potato seekers who aren't quite dead, beware, be on guard, there's calculus ahead. Huh.
We should heed their warning. These are learned people. They made it rhyme in English.
Thank you, Greg, for confirming my hypothesis. Now, payment. Give me the thing.
I don't want to give you the thing.
Give him the rock, TK.
Fine.
Alright, let us depart. Come on, Fabio. We are going to save the world.
Tourists.
Reach the wizard. Reach the wizard.
Hold up. Look over there.
They're what?
Another rune. Thankfully, these people use the same Arabic numerals as us.
What convenience! By the laws of cliché, this must provide a clue to the location of the potato.
Wait, so if we can find this graph of the function, it cannot possibly be anything but a map of the path we have to get to.
But the polynomial has no end. It's going to be like 1 plus x squared plus x cubed. My calculator won't let me do that.
Hold your donkeys, TK. When you reach my age, you'll find some infinite series polynomials approximate other functions. You know how with increasing orders of polynomials the graphs become more squiggly and complex?
Sure.
Well, with infinite orders we can make them look like other functions. But wait, there's more. Most functions can be modeled with polynomials that follow a pattern.
Like 1 plus x squared plus x cubed to infinity and beyond. So what does that pattern look like?
It's pretty simple. Just 1 over 1 minus x. Another fun thing you can do is mess with x by substituting things. Like, you can model 1 over 1 minus x squared by using x squared whenever x appears in the polynomial, becoming 1 plus x squared plus x to the fourth, and so on. Additionally, you can derive and integrate the function and polynomials like ln of 1 minus x, which is the integral of 1 over 1 minus x. That makes it series x plus x squared over 2 plus x cubed over 3 and so on.
Can you do this stuff with other functions?
Sure, there's a whole list of common functions you can model easily, like sin x, e to the x, and others. And even if you don't want to use the entirety of the series, you can use the first few terms and then calculate the error by using the next term in the series at the maxima in the interval of interest.
Right, my attention span is on its last legs, so let's find that spud.
So if I arbitrarily define north as positive y, put us on 0, 1, right, that should be the path we need to follow.
Interesting.
Wake up the rocket, it's fly,
Reach the wizard.
it's fly. Wake up the rocket,
Reach the wizard.
it's fly.
Why are we still walking? We've nearly reached the asymptote, but we haven't found anything.
Patience, TK. We will follow the path laid out before us. It's not like we actually have anything better to do.
Actually...
Shut up. We keep going until we see something of note.
Like this?
Oh, that's nice.
So we can use a function with a known infinite polynomial to get this one, right?
No, we can't. We'll actually have to calculate it.
Actually...
Shut up. Now, we have to find the polynomial without using previous functions.
But how?
Let me give you a little something. What is the coefficient of x to the 0th power if the polynomial equals 1 at x equals 0?
Oh, it's just 1, because when x equals 0, all terms become 0 besides that 1x to the 0.
What if the derivative of that polynomial was equal to 2 at x equals 0? Then what would be the coefficient of the x to the first term?
Let's see... And the derivative of the x to the first would become the new x to the 0th, so 2.
Correctamundo. What about the coefficient of x squared if the second derivative is 3 when x equals 0?
Now it would be 3 divided by 2, because when you take the derivative of x to the squared term, you multiply the coefficient by 2.
Then the next coefficient with the next derivative being the next number.
4 over 6, because now the coefficient's been multiplied by 2 and 3. Now we see where we're going. Each term is the nth derivative at x equals 0, divided by n factorial times x to the nth power.
Yep, and that is how to find an infinite polynomial given any function. Continually find the nth derivative at x equals a times x minus a to the n, divided by n factorial until you see a pattern.
Wait, what's this business about an a?
Well, if you're not doing the full polynomial, a is the x value where the polynomial is most accurate. As you get further away from a, the derivation from the function, and you get incomplete polynomial grows.
Wow, math is weird. So for the polynomial to model cosine, the first thing would be the thing at that divided by the thing, the next thing would be the thing at that times the thing divided by the other thing, the third thing would be the second thingy at there times that thing divided by that other thing.
So you would get 1 plus 0x plus negative x squared over 2 plus 0x cubed over 6 plus x to the 4th over 24.
But you don't need to include those 0 terms. They're pointless, like ducks.
Actually...
Shut up! So for the overall summation formula is x to the 2n over 2n factorial times negative 1 to the n. Yes?
Cool, I'll write it down. Now what? Did that get us closer to the potato?
I guess we'll just continue on this path.
Whoa, this must be a cave, yeah. I remember stories my father told me about these things. Supposedly, they're holes in the ground.
Really?
It's pretty dark.
Wow, how are you carrying that in your pocket all this way?
I'm prepared for everything.
Darn it. What do we do now?
Hold on. Look, signs. Fabio, illuminate.
All these paths, They're marked with infinite sums. And what does it mean by take the divergent path?
Well, when you have an infinite sum, sometimes it adds up to a real number, and so the series is described as convergent. When it adds up to infinity, it's divergent. I assume the path to the ever-glorious potato is down the path matched with a divergent series.
But how do we know which series diverges and which ones converge?
Well, there are a couple of tests we could do.
How many?
8?
See this face? This is not my happy face.
Hold on, they're really simple.
Sure.
First, there's the geometric series test. If the summation formula is in the form a to the nth power, the series converges when a is less than 1, and diverges if a is greater than 1.
What if a is 1?
Well, 1 to any power is still 1, and 1 plus 1 plus 1 plus 1 forever is infinity, so I guess it diverges.
And there's 7 more tests.
Yes. There's the p-series test, where if the summation formula is in the form 1 over n to the p power, the series converges when p is greater than 1 and diverges if p is less than 1.
So it's sort of like a reverse geometric. But then again, what if p is 1?
That's another test. Such a formula is called the harmonic series. Harmonic series always diverge.
Cool. What if we multiplied it by -1 to the n?
Then we use the alternating series test. We remove the -1 to the n part. The remaining formula approaches 0 as n approaches infinity, and each term is less than the previous term, it converges.
And diverges otherwise?
Actually, it tells us squat. It could converge or diverge. That's a common result with a lot of these tests, inconclusiveness. Like the nth term test, if the formula does not approach 0 as n approaches infinity, we know for sure it diverges.
3 tests to go.
The direct comparison test is a popular one. If you're working with positive terms, you can compare it to another known formula. If each term in the formula is less than the known one, if the known one converges, then the tested one converges. If each term in the tested one is greater than the known and the known diverges, so does the tested.
Suppose that would be the case.
The integral test can only be used if the terms are positive, continuous, and decreasing, but it's where you take the integral of the formula as n approaches infinity, and it mimics the summation of the formula. If the integral bit converges, so does the summation.
Is the last the least?
Actually, it might be the most important. With a ratio test, if you put the absolute value of the formula at n plus 1 over the formula n, then we find out where n approaches infinity. Then if the result is less than 1, it converges. If it's greater than 1, it diverges. And if it is 1, then it's inconclusive.
Why is that one the most important?
Because you can use it to find the interval of convergence of an infinite series polynomial. Basically the values of x where the polynomial doesn't become infinite.
So you get the ratio test result in terms of x, all less than 1, because it converges when that is the case.
And that'll tell you the x values where the series converges. Good job, TK. You get a cookie.
Thanks. Which path diverges then?
Let's see, it would be, well, I guess it's that one. Fabio, did you do your test correctly?
Yeah, Fabio. What gives?
The floor.
What?
いつも一人で
wasn't so
歩いて
Is everyone alright?
Well, I'm half left.
Wow, this place is pretty large. If the housing market isn't too bad in this area, I might consider purchasing this place as a summer home.
Look, the path continues down there. Let's head down this pointlessly long spot. Don't let my little brother get my PS3!
What was
That. Run.
You have been trespassing into my sovereign nation, Scrublandia. So you are now under jurisdiction of those laws. And, according to those laws, you are now citizens. Congratulations!
Aw, thanks.
However, as citizens, you now owe taxes.
Oh god, no.
Oh god, yes!
Quick, Fabio, in order to defeat this monster, we must use the skills we've learned through our quest.
How would we apply them?
Well, I I suppose we could look at the tax forms he'll give us and see if... Hey, wait, where are you going?
Gah! Ow! I'll get my lawyers for this, you libertarians!
My word, it's the ultimate object. The potato. Fabio, we must bring it back to the motherland, breed more of its kind, create an agricultural revolution, and save millions from starvation.
Nom nom.
Guess what? I got a fever. And the only prescription is more cowbell.
Two.
We don't need a
We're
count.
start. I already pressed the start button.
Okay.
Go.
Oh, hi, Mark.
Okay.
Wrong
so
side.
Let's start on rap. Greet. What are you selling anyway?
I call it fairy dust.
Greetings.
Oh, hi. Highly concentrated magic. You didn't say your line!
Yep, and that is how to find an infinite polynomial given any function. I am a lemon. Stop. We got that.
Okay.
We're good.
Next thing would be the thing that times the all these paths, they're marked with infinite sums. And what does it... Why... But then again, what is if P is 1 and I am not doing these lines correctly?
What was
That.
your face?
Started.
Alright, now start running.
Oh my god!
Alright, we're good. We're good. Beautiful.
I need to turn that one down a bit.
No, we're done with that scene, I think.
That's gotta go on the blooper reel.